Let's take a closer look at the registers of the Dynamixel motor. In this PDF here, which could be found in the description below, we have all the registers listed. Now, there are two parts of the registers, the EEPROM and the RAM. Now, in these sets of tutorials, we're going to be focusing on the RAM. The RAM is what is called a volatile memory, meaning that once you turn off the power to the motor, the values will reset themselves. The EEPROM, on the other hand, once you change the value, it will always be changed unless you explicitly change it again. Another thing to note is the access. The access tells you whether or not you could read and write to a register. So R means that it's read only, meaning that you can't change it. You could only read the values. And R and W means that you could both read and write to it. On the third page, you could find the predefined variables. The predefined variables are just variables that already have a value associated with them. And you can see that all the registers already have variables associated with them. So if you wanted to work with register 24, instead of typing in 24, we could type in this variable right here, and we'll use it in our example later. In this video, we're going to write a small program that is going to manipulate registers 24, 25, and 36. Register 24 will allow us to turn on or off the torque on our motor. 25 will turn on or off our LED, and the 36 will return our present position. So what we're going to do is we're going to write a program. We're going to turn off the torque, allowing us to physically change the position on the Dynamixel motor. And to confirm that the torque is off, we're going to have the LED turn on. And while we physically move the motor in a different position, we can return the position using register number 36. Let's jump to the Arduino IDE. I've already included the library and started the setup and loop function. The first thing we're going to want to do is to open serial port, and we could do that by doing serial.begin with a baud rate of 9600, and then we'll delay for 3 seconds. This will give us time to open the serial monitor. Now the next thing we're going to want to do is turn off torque. And we could do this by doing the set register function. And that's AX12 set register. My ID is 11. And instead of typing in 24 for register 24, we could just use the predefined variable. And this makes it easier to read the code. And to turn it off, we'll send a value of 0. Next, we'll need to create a value to store the torque value of 0. And I'll create my variables up here. So variables to store data. And we'll do int torque val, and we'll just set it to -1 initially for default. And we'll also need a motor position to store the motor position later on. So I'll just go ahead and create it now. Now we'll use our our torque value, and this is to return torque data, so either 0 or 1 for on and off. And our torque value is going to be, we'll use the get register function. So that's AX12 get register, again, ID 11. We could do, we could use the same variable. And we're returning 1 byte of data. So the next thing is to turn on LED if torque is off. And we're going to do that by doing an if statement. So if our torque value is equal to 0, to turn off the LED, we could use the set register function again. That's AX12 set register, again motor 11, and we'll do AX LED, and that will correspond to register 25, and we'll turn it 1 for on. And we could also serial print the LED should be on. And let's see, in our loop function, we're going to want to continually print out the position of the Dynamixel motor. So we'll start off by printing out the position value is, and then we'll set our motor position variable to get the value. Get register to AX present position. So not get register to, sorry. So get register AX present position L, and this is the predefined variable for the present position, and it's going to return back 2 bytes of data. And then we'll print out the motor position, and then we'll print out a new line. And we'll delay for 1.5 seconds. Okay, let's look at our code. So what's gonna happen is that we're going to first turn off the torque of our motor, and let's not forget our delay. Now in my experience, if you do a register function back to back, sometimes it doesn't go through, so it's always good practice to do a little bit of delay in between each register function. And make sure I do a small delay here too. And let's so again, the overview, again, what we're doing is we're going to turn off the torque, and we're going to store the value of the torque, so it should be 0, and we'll do an if statement to turn on our LED, letting us know that our motor the torque is off, and then we'll also print it out for confirmation. And then during the void loop, it's just going to print out, once we manually move the position on the Dynamixel motor, we can print out the position as well. So let's check our code. And it says here, missing my semicolon. Okay, so let's go ahead and upload our code. And then serial monitor. And so you should see the LED should be on, and if you could see it, the LED in the back of the motor is on. And the torque, which means that the torque should be off, so we could physically move the motor. And then you could see that the corresponding position will be printed on the serial monitor.